Go ahead.
Hi Richard Y, this is Danny, and I just decided to dedicate this video to you because you had requested it. You had enjoyed my other videos, but this one will be a little more technical, but not that much. It's just rudimentary rocket science. I just do that as a hobby, folks, but I just decided to continue in that vein here. But so, here we go, Sandra. Let me sit down, and then I'll get you the, no, you're going to get the camera, so I can explain everything that's going on here. And it's great to see all of you again. And Denise, I hope you enjoy the poetry as well. I'll make it so that we can see the entire sheet. Yeah, there we go. Now, steady as we go. This is called mass ratio. Now, this is called fuel plus the structure divided by...
Oh, sorry.
What are you doing? Over the payload equals the mass ratio. Now, the mass ratio is what we use all the time. Think about it this way. You need fuel. That's what's in your body. You need structure. That is your body. The payload could be anything you're picking up off the table. That will require a mass ratio. Going into space is no different, overcoming gravity. You want, in the early days, a lot of fuel, less structure, and less payload, the better. That is the mass ratio. Now, this example here is, well, we can see that's the Saturn V rocket. I don't draw too good. You got to talk to Sandra about drawing. But this is 6,500, well, 6 million pounds. That's what we want for our rocket. Fuel and structure. Now, what we need to get into orbit is 650,000 pounds. The mass ratio then becomes 10. So you need a 10-to-1 mass ratio to get this thing into orbit. It's about 100 feet long now in cylindric as I speak. The astronauts sit here, service module, lunar module packed away here, behind these what they call SLA panels, solar panels, and then we have the booster material. That all weighs 650,000 pounds. That's our 10-to-1 mass ratio, and this is about 100 feet long. Also, to get into orbit, we have to require thrust. Now for thrust, on the Saturn V, we require 1 million pounds of thrust. That means that the 6.5 million will give us the 7.5 million, which means that's 1 million pounds of thrust. So the magic number for Apollo is right here. 0.866 times gravity, 32.16, plus gravity, 32.16, equals 60.03 feet per second. Now we go up. Now, at the same time, we can also say, as we go up, we should clear that 400-foot tower, because it's a 360-foot, 400-foot tower, 360-foot rocket, clearing that. That should take about you would say 6.6 seconds. That's fine, but it takes a little longer, you see, because the rocket, like this pen, goes up. It doesn't just go straight up. It rattles around from all the vibration. And the engines at the bottom are trying to balance it and keep it straight. And that adds time to clearing the tower. After that, we're off. Now, in the early days, here are the fuels that we needed to do this. Alcohol fuels in the Mercury program were used only. I'll talk more about fuel another time. This here is one of the alcohol groups, C2H60. Don't drink the others. And I'm not kidding. So, C3H80 is another alcohol group. C1H4O is another alcohol group. So you have methyl alcohol, propyl alcohol, on and on. Anyway, but fuels all need an ignition source. So don't drink a flaming rum punch. I've actually seen people with burned faces doing that. Because if you ignite that on your face, you're in trouble. So don't ever do that if you're drinking alcohol. This group only, of course. But in any case, I'll talk more about what fuels spacecrafts later and what the amounts are, etc. But this is just some of the rocket science basics. This is the chemistry. That's the last part. But remember the equation. It's called mass ratio. Fuel plus structure divided by payload will give you a mass ratio. And so go to your table and pick something up and figure out your own mass ratio. How much fuel you put in your body, what your body structure weight is, and how much the weight is. Everything's about weight. The payload is that you're picking up off the ground, off the floor, on the table, off the table. That is your mass ratio. Alright, thank you very much, and I'm Dan Reagan. You can visit me at MusicYoda.com or see me on Facebook or YouTube. Either way. Thank you, folks. Dancing124 is my YouTube channel link. So, DANSING 124, I'll spell that for you, because the S is because I do sing, but not this time. I'm granting a request. Thank you, Richard. It's been very nice to grant this request for you. And there will be more of this kind of thing or anything else. And thank you again, Denise, for asking me for the poetry. That's all I have right now. I'm glad you're friends with Bob now, too, because he's got plenty of poetry, too, and songs. Thank you.